Hi, everybody. Welcome back to Dave's Math channel. This is my continuing feature on the Math Lovers book. And as I do every Saturday, I'm featuring a biography of another famous mathematician throughout history. I have these listed at the end of volume 2. I have 80 of them listed chronologically. And I'm up to the 31st of them, which is Thomas Malthus, who lived from 1766 to 1834. And Thomas Malthus was a British scholar. He wasn't so much a mathematician, but he did apply mathematical theory to his study of population growth. He wrote a very important essay. It was called an essay on the principle of population. And what he basically says in this essay is that world population or population of a society tends to grow exponentially. That's this red graph. And this is now also called Malthusian growth. Exponential growth is called Malthusian growth in his honor. And what he was claiming in this book was that although population is growing exponentially, our food production, our resources are only growing linearly. So he was kind of warning us that we're going to reach a point where, we no longer have enough food to sustain everybody. People are going to start starving. That's this hollow circle where you see these graphs crossing. So it was a pretty alarming book he wrote. Um, the good news is he wasn't really correct. I mean, our resources did grow exponentially, and besides, world population growth has slowed way down, I'd say, in the last 50 or 60 years. But yeah, so now I'm just going to show you some graphs of world population. This is the world population or estimates of the world population from, I guess, the semi-nomadic era starting around 10,000 BC up till today. And this is actually a semi-log graph. So what this graph is actually showing is that for most of human history, the world population was actually growing even faster than exponentially. Because if it was just growing exponentially, this should be flat, but it's obviously not. But I just kind of want to explain what's been going on different types times in our history. So I'd say from around 10,000 BC to around 4,000 BC, world population wasn't growing very fast. I mean, I guess this was kind of early agricultural era. I think it was growing a little bit, um, but not very much. Things were pretty stable. But then we have the era of city-states starting around 4000 BC. That's when we had all the ancient empires like ancient Egypt, ancient East, Greece, ancient Rome, and that allowed we had a lot more technology during this period. We were able to grow a lot more food and sustain a lot more people. Our population grew quite a bit during that time, from around 4 million to around 100 million. And then we had the year of empires, I guess, starting around the time of the birth of Christ till around, the beginning of the Industrial Revolution. That's this purple region. And I guess things slowed down a little bit then. I don't know. I mean, maybe, we had the Middle Ages. We had a lot of catastrophes. I think you can even see it dips a little bit in the middle here. I think that was the bubonic plague during the 14th century, which killed about 1/6 of the world population. Um, but it did eventually start growing again. The thing that really made it grow super fast was industry, the Industrial Revolution, which I guess they call the global era. This orange region on the right, going from around 1750 to today. We had all these new resources and we had mechanization that just allowed for, it was like a exponential growth in technology, which allowed for exponential growth in population and in resources. Um, but I think it's also worthwhile to look at just the Industrial Revolution from around 1750. The dark blue region. So there's two graphs on this picture. The region that's colored dark blue or blue is just a regular graph showing absolute population versus time. But then the red graph is the population growth rate. So this is kind of like the Seminole graph. So if you look at this graph, Malthusian population growth, this red line would be flat. It would just be a fixed percentage per year. But actually, it wasn't fixed. It actually peaked, I think, in 1962. If you look at the peak of this red graph, it's 2.1% per year. In 1962, the world population growth rate was about 2.1% per year. That was really, really high. I mean, that meant the world population was doubling roughly every 35 years. And it pretty much did double from, around 1962 to around 2000. I think 1962, the world population was around 3 billion. And then by the year 2000, it reached about 6 billion. Now it's about 8.2 billion. And it's been slowing down. That's the good news. The world population growth is actually slowing down. This used to be a much bigger problem than it is today. I mean, I remember when I was a kid, in the early 70s, when I was about 10 years old, used to hear all these people really alarmed about the population explosion. They were saying that our world population was growing way too fast and we were in danger of running out of resources and starving to death. And there was a lot of mass starvation. I remember hearing that, 2/3 of the world was starving, which was true, I think, in the 70s. Now, I don't think it's anywhere nearly as bad as that. I think maybe now it's about half. It's still a lot of people, but there's a lot of things that's helped. For one thing, world population's not growing as fast as it was. For another thing, a lot of the world's become industrialized since then, and also, we have GMOs now. We're able to grow a lot more food than we did, so I think there's a lot more resources now for everybody. Um, you know, if this projection is correct, it goes up to the year 2100. I guess what they're saying in this graph is that by the year 2100, our population growth will essentially have gone to zero. World population will become roughly constant, which I think will be a good thing. Um, but what else do I want to say? Malthus was very influential to Charles Darwin. It turns out, as a matter of fact, his essay on world population growth was a big part of his inspiration for his theory of evolution by natural selection. So now I'm going to start talking about, ecosystems and population growth and decline of predators and prey. So this graph here shows, populations of lynxes and hares. I guess the lynxes were the predators and the hares were the prey. And I think it's kind of instructive to think about. I think you notice that when you've got these cycles, you've got kind of oscillations of both population. And you might wonder why this is. Well, if you think about it, it should make sense because suppose that your lynx population was small and your hair, then the hares can reproduce. They have a lot of babies, and if they're not getting eaten, their population's going to grow very fast. But then what happens is, then the lynxes have a lot to eat because there's all these rabbits running around. So they start eating a lot of the rabbits, and then the rabbits start dying. Their population starts going down. But once their population goes down, then the lynxes start starving because they don't have enough to eat. So then their population goes down. So I think you can kind of see, how these cycles occur. And if you think about ecosystems, this is very critical in Darwin's theory because if you think about how can a particular species flourish? For one thing, it has to have enough to eat. It has to have enough resources, enough food. If there's a drastic change in the environment, then that could wipe out a lot of the resources, and this is actually what happened after the meteor that caused the big dust storm 65 million years ago that killed the dinosaurs. What happened was there was a big asteroid that hit, I think, the Yucatan Peninsula near Mexico, and it caused a big dust storm for several years. It blocked out most of the sunlight, and that killed most of the plants. And then the dinosaurs didn't have enough to eat, so that's how they became extinct, according to this theory. And so when there's drastic change in the environment, that's kind of what drives evolution, because the mammals survive. The mammals were just these little shrews that were kind of crawling in holes, and I guess they had enough bugs and stuff to eat, and they ended up flourishing. So I think this is kind of what influenced Darwin and his theory of evolution by natural selection. Malthusian population growth was a big factor in that. So I just thought I'd mention that. And that's pretty much everything I have to say about Thomas Malthus and Malthusian population growth. So thank you for watching. Long live math, and I'll see you guys next time. Bye.